AI is the first thing that has no limit.
(1950), a computer science lab in Manchester, England. A machine plays a perfect game of checkers. Not chess, that would come later, but this simple game marked the first time a computer performed a task that required thought. This wasn't just code following instructions. This was something new. But the real first AI? That's more complicated than anyone expected. The answer changes everything we think we know about artificial intelligence. 1943. Warren McCulloch and Walter Pitts created something revolutionary, the first mathematical model of a neural network. Their paper described how neurons might work together to compute basic logic. It wasn't a computer program. It wasn't even a machine. It was an idea that would change everything. 2 years later, the ENIAC computer filled a massive room at the University of Pennsylvania. While not AI, it set the stage for what was coming. The race to build a thinking machine had begun. Every day, AI reaches new milestones that were once thought impossible. Our community tracks these breakthroughs, connecting past innovations to future possibilities. Subscribe to join us as we chronicle the ongoing evolution of artificial intelligence. 1952. Arthur Samuel didn't want to just program a computer. He wanted it to learn. His checkers program became the first self-learning program in history. It played thousands of games against itself, improving with each match. But across the Atlantic, Christopher Strachey was pushing boundaries at Manchester University. His checkers program could think 6 moves ahead. The battle between different approaches to machine intelligence had begun. 1956 brought the logic Theorist, created by Alan Newell, Herbert Simon, and Cliff Shaw. This program could prove mathematical theorems. It even found a more elegant solution than the one in Bertrand Russell's famous Principia Mathematica. Then came the general problem solver. Unlike previous programs designed for specific tasks, it could tackle any problem that could be broken down into smaller parts. Some called it the first true AI. The field exploded with competing claims. Frank Rosenblatt's Perceptron promised to recognize visual patterns. Joseph Weizenbaum's ELIZA simulated a psychotherapist. Each pushed the boundaries of what machines could do. 1965. The Soviet Union reveals their own AI programs. The space race becomes an AI race. Funding pours in, but results don't match the hype. Critics ask challenging questions. Were any of these really intelligent? Or just clever programming? The debate sparked fundamental questions. Does true AI require consciousness, self-awareness, the ability to learn? Each potential first AI raised new philosophical challenges. Marvin Minsky's microworld programs could reason about simple block arrangements, but they failed completely when faced with real-world complexity. The truth emerged slowly. There was no single first AI. Instead, artificial intelligence evolved through multiple breakthroughs, each adding a crucial piece to the puzzle. McCulloch and Pitts laid the theoretical foundation. Samuel showed machines could learn. The logic Theorist program proved they could reason. ELIZA demonstrated natural language processing. Each step forward revealed how complex intelligence really is. The real breakthrough wasn't any single program. It was understanding that intelligence isn't one thing, but many working together. Today's AI systems combine all these early approaches. Deep learning uses ideas from neural networks. Game AI builds on Samuel's work. Natural language models extend ELIZA's capabilities far beyond what anyone imagined possible. The search for the first AI taught us something profound. Intelligence isn't a destination. It's a journey of continuous evolution. Next week, we'll examine how modern AI is redefining intelligence itself. The question isn't which AI came first. It's what these pioneers teach us about where AI is heading next.